Okay, we're starting out. This video is especially for 7th period because rather than Miss Gill teaching the math stuff, if she doesn't feel comfortable with it, I'm going to teach it from the internet. Even though at this moment when 7th period's listening to my voice, I'm driving to the high school to get on a bus. Whoa, it's like time travel. Not really, at all, whatsoever. Anyway, so my name for today is going to be...
Richard. Richie Rich.
No, Mike is...
Slim Shady. Yes, no. Steve. Swerve. Did you Swerve. Slim Shady.
Oh yeah, Sammy, come back in.
7. Oh, so your name's 7th period. Is your last name?
My middle name is Period. My last name is Special. Two-step inequalities. Now, we've already done... Yeah, yours should say 4. Yes, it's a wasp. Chill. Be quiet. Okay? Right? Absent. Now, you have a 4 here. It says, last period there were a lot of people that were really, really confused about inequalities compared to equalities. There's only going to be one difference between the two as far as how we solve for them. And I'm going to go ahead and say it right off the bat. So I want you guys to create a box that we're going to use to highlight. Excuse me. And it's going to say when multiplying or dividing by a negative, switch the sign. And what I mean by switch the sign, you are going to be taking your less than symbol, and when you do that, when you divide or multiply by a negative, you are going to make that less than symbol a greater than symbol, or make your less than or equal to symbol a greater than or equal to symbol, and vice versa. So that's for later. It's actually on your homework, not in any examples on this. The examples are easier, which I apologize for. The diagram at the right models the inequality 4 plus 2x is greater than x plus negative 2. Notice that the side on the right is lower. The side that is lower is heavier weight. So this here that is the 2x plus 4. Do you agree with our MATs that we've been using, MATS? Yeah? That part is heavier. That's why it's considered greater than. Then we have solve the inequality, the same process used for equations. Okay? Solve the inequality used for equations. We're going to do that next. But first, you're going to take 5 minutes. Actually, I'll do a timer on the screen so 7th period can see exactly when that is. Science, geography, math. Measurement. Yeah. You are going to be doing, I think that's seconds. You're going to be doing that. You're going to take 5 minutes to complete this page. So you're going to be doing the visual representation as well as A through D on that page. D, you might have to get a little creative, but this is what's going to happen. You're going to be completely silent. You are going to recreate the, you're going to recreate this scale that's on the right. I'll do it as well so you can see what I'm doing. And then from that point forward, you're going to be working on it for the next 5 minutes. In 5 minutes, we're going to come back. I'm going to show you what I have, and you can see how you did. It's okay if you don't know what to write, but I do want you to brainstorm a little bit to come up with something. So, go ahead. And I do want you to recreate that so you can erase and cross out and still see what it looked like at the beginning without a problem. As far as those letters go, B, if you're following along the last couple of days, and also when we did the coin activity a while ago. But A and C are two ones that everybody should have. D, most of you should get to, but B as in boy, that's going to be the hardest one, and that's okay if you have struggled with that one. And we're back. Let's see how we're doing. So I rewrote this to represent what was already written above it, or represented above it. The reason why I rewrote it is because I want to be able to erase stuff without it going away, or some of you may have just crossed off what you have above it, but I want to make sure you can see that when we're adding the zeros in there. So the first thing that I had you do is says to get rid of one of these on either side. One of these cups on either side. Boom and boom. That was when we would be saying, okay, on each side of the equation, these are not equations, these are inequalities. Each side of the equation, there's a bucket here, there's a bucket here. Cool. They're represented on each side. I know that that's not the thing that's making this scale tip over. Okay? Then it had you try to represent these guys. We needed to represent those guys, be able to take them away. In order to do that, we had to introduce some zeros in there. So I'm taking these zeros that I'm introducing, hi guys, introducing over here. So now that I have introduced those over there, because it has to be a zero, I have to zero those out so you can visually see I'm taking these guys from the other side because what we're doing, these are just zeros. Do you agree? So if you add zeros to -2, how much do you have? -2. Yeah, you can put as many. Yeah, sure, I'll take a whole bunch of zeros, please. Wonderful. Great. Maybe with a 1 in front. No. Excuse me. But now what I'm going to do is I'm going to take these 4 positive integers and be like, hey, these 4 positive integers are represented on the other side now, right? These 4 here are also represented with those 4. So let's peace out, see you later. So now we have one bucket which represents x. And what is our solution to this inequality? Ooh. What's the solution to this inequality? Yes? X doesn't equal -6 because, look, the scale is still tipped over to the bucket. Yes, x is greater. X is greater than -6. So that means that for all values of x, whatever amount of integers that you wanted to put into this bucket here, as long as it's greater than 6, is it -6? As long as it's more than -6 in there, this will continue to be teeter-tottered over to that side. Yeah, I like it too. Oh, yeah. Gotcha. Yeah, that plus and minus zeros, that's okay if you didn't have that. That part is meh. I like it algebraically anyway. So that's saying that if I run a number line, which is 6, this is 0, this is -6, all values that are greater than, all values that are, get out of there. Thank you. All values that are greater than 6 in that bucket will allow that to stay. And then Jace is like, oh, that's Packers colors. He's in 7th period. I'll give him 7th period shout-outs. All right. Now for this one. State the inequality after removing a cup from each side. So that means, what does the inequality after we've taken away? Well, the cup represents what? X. So we have one less x on each side. Yes, sir?
I put 1 cup and 4 positives on the left and 2 negatives on the right.
1 cup and 4 integers on left. And was it just 2 negative integers? And 2 negative integers on right. And I'm sure a lot of you just wrote this, which is x is less than, x plus 4 is less than, that's greater than -2. And if you had that, you're cool. Except for those that are warm in the classroom. Now, why did you have to place 4 0 pairs onto the right side? The reason we had to do that was to represent using the inverse operation. It is, and that's what it is. By getting the other integers out, that's what we have to do to represent the inverse operation, which is just saying we're going to subtract 4 from each side. Yeah, yep. Yes, sir. Salud. So what is the solution to this inequality? What does our scale show, a to the j?
X is greater than -6.
X is greater than -6. X is greater than -6. Hey, Simon, how are you? Good to see you. X is greater than -6. Now, how many of you had something for D? And who's willing to share? Doing it backwards, okay. What would the action of doing it backwards be? Doing your steps in reverse, making sure that it comes out. Okay, good. Yeah. We're going to substitute in for the inequality. But what are we going to substitute in? Are we going to substitute -6 like we did with the equations? That would be a good idea. However, to make this short, that won't work if you do -6. This is what will work. Substitute a value that is less than 6, or less than, not then. Less than -6. Shouldn't work. Good. Sub greater than -6 should work. Good. Here's what I mean by good. I'll show you in a second. I'll let you copy that down. So you're substituting something less than 6 and greater than 6. Substitute a value that is less than 6. So let's plug in a value that's less than 6 and a value that's greater than 6 into this inequality. So here is the here's the less than 6. 4, or less than -6. 4 times 2. What's a number that's less than -6? Somebody raise your hand. Yes. Nope, that's greater than. Gina. -7. -7 is greater than -7 minus 2. So let's work this out. We got 4 plus minus 14 is greater than -9, which is going to be -10 is greater than -9. Does that work? Is that true? Integer people? Yes. No, that's not true. No. No, sillies. Look, here's your number line. -10 is over here. -9 is closer to there. When you go this way, you get higher on a number line. Okay? So that one doesn't work. When we did a number that was less than -6, was it supposed to work? When we did a number that is less than -6, less than, as in the absolute value is greater than 6 in the negative side, that's supposed to happen. That's supposed to happen. The reason why it doesn't work is this. If we had a scale just like this, if I had -7 integers in here, that would mean that this side is going to be heavier. Because this is only -7 here. Okay? Or it's going to be even actually. So that doesn't have a less than. And I'll tell you this so it doesn't take too much time. If we were to put -2 in here, is -2 higher than -7? Yes. Yes, sir? I wrote yay. Yes, that's how it's supposed to happen. Because I asked you, is that what we wanted or not? Is that what we wanted or not? And it said, right, you know, as we, was that blue on blue? No, that doesn't work. So we substitute a value that is less than -6, and it shouldn't work. That's what we just checked. Okay, that's what we just checked. All right, let's do some examples. This is going to be very similar to what we just did earlier, yesterday we had the same thing. So for those of you that struggled possibly on your homework, hopefully we'll be all right. So for the step 1, I need to see, this is actually just a two-step equation with the one side. So this is 2 days ago stuff. So we have to add, I'm just going to shoot through this because I want to make this video less long. We have to, nope. Come on, erase. Please erase. Thank you. We have to subtract. The first thing we have to do is subtract 9 from both sides. From both sides. Then what's going to be the next step? No, So you're thinking of it too hard. Not the stuff yesterday. This is the easier stuff from 2 days ago. This example. Nope, no division. Yeah. Did I say no division? I'm sorry. I cut you off. A lot of people were doing division last night in their homework and it was messing them up. I'm sorry. You were right. I'm wrong. It is dividing. What are we going to divide? Yes, we're going to divide 2 on each side. I'm sorry. Divide both by 2, so I have 2x is greater than, 2x plus 9 is greater than 25.
And the first step that we did was we subtracted 9 from both sides. We got 2x equals 16. Then with the next step, what we did was we divided each side by 2.
Now, do I need to flip this sign? Did I just divide or multiply by a negative from the thing we wrote first? Do I need to switch it? Yes, sir?
I was actually not saying it's less than.
Oh, thank you. So all values, when x is less than 8, that holds true. That inequality holds true. Any value less than 8. So that means that 7.999999999 would keep it held true.
On the homework say that we put
Are you going to put like something or are you going to put something? Like
greater than that, or less than.
you want to make sure you have the correct sign. That'll be half off if you flip the sign accidentally on the homework. Example 2, this is like yesterday's stuffs. Yep, example 2, this is like yesterday's stuffs. So the first step that we're going to do is combine like terms. We don't have any like terms on the same side, but by doing combine like terms, we're taking these steps. So the first thing I'm going to do is I want to get my coefficient, my highest coefficient, to be stuck with the variable. Which is bigger, -5 or 3? Yeah, 3 is bigger. So I'm going to add, because that's the inverse, add 5x to both. And also I'm going to subtract 23 from this side. Subtract 23 minus 23 plus 5x. Because since the variables are going to the right side of the inequality, that means the integers are like, you guys smell bad, I'm out of here. Add 5x, subtract 23 from both. Remember, the variables are asocial, they want to be by themselves. So after we do those steps there, do you need me to write out what, can I just go straight from here? Does anybody need me to rewrite what I wrote already? It's okay if you do. Add. So after that step, that gives me 0x minus 20 is greater than 3x plus 5x equals 8x, and 23 minus 23 is 0. So that's where I sit. So my next step is going to be Juliet. I have -20 is greater than 8x. divide it. Yes, we're going to divide the coefficient, which is stuck to the variable. We're not going to do decimals because we want to use fractions. So divide both by 8. And I'm assuming and expecting that you know when I say both, I mean both sides of the inequality or the equation for different steps. Divided by 8, divided by 8. So on this side, I just have x. And on this side, I know that 8 times 2 is 16. 8 times 3 is 24. And 20 is halfway there. So it's negative 2.5 equals x. And also because I did it earlier. Divide both by that, and that means that x opposite 2.5 is greater than x. Sweet deal, banana peel. Next one. I'm interested why the distribution property is here. I'm going to ask Mulcahy about that, see what she would do in that situation, because I don't see exactly what we'd be distributing there without creating more trouble. So for this step, is this the one where we have to do division first? No, because it's not a full fraction on the one side. The first step that we're going to do is just add 7 to both sides. Plus 7 plus 7. And that would give us it's greater than or equal to 18. Where do we go from there, Will?
We divide 18 by 3.
Okay. No. Here's why. What's the inverse? If you were being divided by 3 and you're like, stop dividing me by 3, what would you have to do to make sure you're not being divided into 3 pieces? Multiply yourself 3 times, right? Yeah, so then there'd be 3 wills. Multiply both sides by 3, so we have m is greater than or equal to 54. It's still similar to what you guys did yesterday. The only difference is this. And also, I want to make sure you know how to represent it on a number line, because that's what the homework's like. But you guys should know how to represent integers on a number line anyway. We've had that 4 years in a row. Special exception. Yay, fraction bars. So are we doing SAD MEP right away?
Yes.
No, because there's a fraction bar. This is one of those special exceptions. Like SAD MEP is even more SAD. All right? It's the elongated sadness. So the first step I have to do is multiply both sides by 2. So that leaves me with n minus 11 is less than or equal to negative 12. And the next step is going to be just add 11. So the variable wants to be by itself. Remember, they're asocial. So n is going to have to be less than or equal to negative 1. Good. I love hearing people say that it's easy. Now here's one that isn't as easy, and this one's like a 6-step one, but that's fine. First off, I want you to change
I'll do it the same way as I did last period. Change that to a less than symbol. That should not be equals, because we're not doing equalities. So when we have fraction bars on both sides, what you're going to be doing is you need to, I must multiply both sides by product of denominators. I must multiply both sides by the product of the denominators. And product is the answer to a multiplication problem. What is the product of the denominators over there? 4 and 9. What's 4 times 9? 36. So that means that I have 36 is being multiplied by... Where's my notes page? Here we go. 36 is being multiplied by c plus 8. And that's going to be, I said it was less than, correct?
Yeah.
And 36. 5 minus c. 9. Because that's just like 36 over 1 multiplied by that. So there's one step right there. Then the second step is, good, we have just enough time to finish. Now, if you remember how to, if you've had this before, the way that this works is there are 9 4s in there, and there are 4 9s in there, so it's going to come out to be like this. There are 9c plus 8 is less than 4 5 minus c. Ugh. There's only one. On the test, I'm going to look and see if these are on there. I got to look at the test a little closer. So now I have to distribute this 9c plus 72 is less than 20 minus 4c. Ugh. So there's 3 steps right there on these 2-step inequalities. See why I skipped that one yesterday? Excuse me. So there's 3 steps. Now we start the 2-step inequality. So which one is more? There is 9c higher than negative 4c? Yeah, negative 4c. Which is negative. It's a reduction of 4c. So with that state of mind, Nick, you could say this if you want. 4c is lower, so I want to bring the 4c over here, plus 4c, plus 9c. Then my 72 is like, ooh, you see smell. So I have to go minus 72, minus 72. Oops. So what am I left with on the left side of the inequality, Josie? 9 plus 4. 9 plus 4. I have 13c is less than. Hawk, what you got? (13c) is less than negative 52. Fantastic. We're off to a great start. Finish. Now we have to find out what c is. And Britton, what's the next step? Divide them both. By how much should we do? 13. 52. I'm thinking it's 4. I'm thinking it's 4 because 3 or 12.
No,
13.
4 times 3 is 12.
Yep, because 4 times 3 is 12. 4. I don't know. 5 wouldn't work. 4 times 13.
And a half.
Yeah, because 40 times 10. 4 times 10 is 40. Plus 4 times 3, which is 12. 4.
I thought it was 53.
C is less than 4 for every value on a number line where C is less than 4. And to make it go like your homework, doom. Don't pack up. This is like your homework. No, stop moving. I don't want to hear zippers. Start writing. Write what I'm writing. So it's C is less than 4. So it doesn't include 4, so it's an open circle. And it's this way. All numbers that are included in there, and it goes on forever. McGuigan. You're right, I'm wrong. It is -4. My fault. Thank you, good catch. Sorry, 7th period. I know you're all groaning. Whoops. Sweet. Question?
These, since they're so similar, could you just take out the inequality symbol and add?
You don't want to take out the inequality symbol because of what you highlighted at the very beginning. Because if you multiply or divide by a negative integer, you need to flip the sign. Because do you remember what another word for negative is? Opposite. And what's the opposite of less than?
What? Greater than.
Greater than. What's the opposite of greater than? Yeah. Okay, everybody say goodbye to 7th period.